Okay, in this problem we have a police officer in his car at a red light. He's waiting for the light to turn green. And there's a speeding car in this other lane here that goes right through the red light and continues moving along at a constant velocity. At the moment the car goes through the red light, the police officer immediately puts his foot on the accelerator and accelerates constantly down the road. Okay, so let's take a look at this scenario and then analyze it. This data was collected using a video camera, and then that movie was imported into LoggerPro, and then I did a curve fit on each set of data. Okay, this data is for the car traveling at a constant velocity. It's a position versus time curve, by the way. And this data here is for the car that accelerated. Okay, this is where the two cars are at the same position. It's where the lines meet. And you'll notice that this curve here has a steeper slope than the other one. So that means the car that was accelerating, when it caught up to the other one, it was traveling faster. It actually turns out to be twice as fast as the speed of the car traveling at a constant rate. Now I did, like I said, I did a curve fit. I did a linear fit on this. And what we get here is the equation x is equal to mt plus b, where m is the slope. Now, what does that represent? Well, I am plotting here x versus time. So this is the position, this is the time, so the slope would be the velocity. Okay? And it tells us that the velocity here, which is the slope, is equal to 0.4014 meters per second. The curve fit on here, what I did there was a quadratic fit. And what's displayed here by the computer is x is equal to a t caret 2 plus b t plus c, where x is the position, t is the time. Now here we have time squared, here we have this time, and doesn't this match up to the equation that the position is equal to 1/2 the acceleration of the car times the time squared plus the original velocity of the car times time plus the original position. So coefficient A, which is equal to 0.1679, is equal to 1/2 the acceleration of the car. So the acceleration of the car then is equal to twice coefficient A. So we have 2 times 0.1679. So that gives us about 0.3, maybe 0.33 meters per second squared. Okay, so that's how you do curve fitting, and this is a very valuable tool in this course.